I think we're all logged in and we all have our data on the Palmetto. Now let's talk a little bit about the structure of the Palmetto cluster. Okay, so the Palmetto cluster is really just a bunch of computers. And most of these computers are what we call compute nodes, okay, and they look like this. But some of these computers or some of these servers are special computers. One of them is called a PBS server or a scheduler, and we'll talk about that later. But there's another one called the login node, okay, and that's the one that listens to people that want to log into the cluster. So the login node runs a secure shell server, and the only other computer you need to know about is your own local machine or laptop. And your laptop runs a secure shell client. So the server talks to the client and lets you log in to the login node. So whenever you log into the cluster, that's where you're put. All of us right now are actually executing commands onto the login node. The login node is not a very beefy computer at all. Well, it is, but it's not the one where you want to run your jobs. Okay, that's not where all the heavy computing needs to be done. Actually, you want the computing to be done by the compute nodes. Unfortunately, you can't just say, I want to use all of these compute nodes right now, run my job on the compute nodes, or run my commands on the compute nodes. You need to go through something called a scheduler. The scheduler actually looks at everyone that's using the cluster, what resources they need, and decides when to delegate what jobs or what compute commands to the compute nodes. All right, so that prevents me from logging into the cluster and just running my commands on all the compute nodes without any regard to anyone else using the cluster. Okay, so the scheduler takes care of that. So you don't have any access to the compute nodes directly. You have to do this via the scheduler node. And most of what we learned today is about how that process works, okay, and how you can do this. Is that clear? Any questions about how the cluster is just laid out? All right. So when you log in, you see that you see that you're put in the user 001 or the login node. The first thing you're probably wondering is, okay, how do I actually use a compute node instead of running my commands on the login node? Okay, so one of the commands you'll use to do this is called qsub. And qsub actually is a specialized command, and one of the switches you'll give it is the I switch, which tells the scheduler that you want to use a compute node interactively, okay, which means you want to enter commands into the compute node, just like you're doing with the user login node right now. And we'll see that that's somewhat different from how you normally use the cluster, which is in batch mode. But for now, we'll stick to an interactive mode. So we'll say qsub I, and then you have to specify a set of resources that you want from the cluster. Okay, and to do that, you have to use the else switch. For now, we'll just ask for one node, one compute node, and within that one compute node, we want a single CPU core. Okay, that's all we want access to. When you hit enter, you're presented with some output. The first one is a warning that says impractical, not rerunnable, which means that anything that you execute here can in no way be reproduced. You just have to go through the entire process again. And then you have some other lines of input. But the most important line you see is what the final output of this action is. What do you see that's changed? What's different now from when you first logged into the cluster? Sorry, what? Right, so you see that we call this the prompt. The first few characters that appear before each command is called the Unix prompt. you see that the prompt has changed a little bit. It says that you're no longer in the user login node. Right now you're logged in to a compute node, and this is a fairly beefy node. Okay, this one can handle heavy computations quite easily. So any commands that you enter here are actually being executed on a compute node, on one of these guys. Okay, so let's exit out of there. And to go back to the login node, all you do is type in the word exit, and that kills, or that finishes your interactive job, and it takes you back to the login node. All right, so we didn't do anything special. All we did was we logged into a compute node and then we logged back out, and we didn't do anything inside that compute node. Okay. So how do you know how many compute nodes there are on the Palmetto, and what compute nodes are free currently? Okay, so there's a special file in etc in this directory called /etc, and it's called hardware table. Let's see. It's a text file, so how am I going to look at its contents? Yeah. Okay, hopefully that'll work. All right. So it's a text file that basically tells you, or it's what it's described to be. It's a table that tells you what hardware is available on the cluster, on the Palmetto. Okay, so this is fairly confusing, so let me walk you through it. The Palmetto cluster is made up of several phases, okay, and each phase has a certain kind of hardware. Okay, so you see that the cluster is made up of phases 0, 1, 2, 3, 4, all the way up to phase 13, and there's probably more. And each phase has several nodes, right? Has several distinct nodes. So for example, phase 5A has 383 compute nodes. Each of these nodes has a processor that's an Intel Xeon L5420, and each of those processors has 8 CPU cores, 16 gigabytes of RAM, and we'll talk about local scratch in just a bit and interconnect a little bit later. But if you look at phase 5A, the total number of CPU cores that's available in phase 5A is basically 383 times 8, right? So that's the total number of CPU cores in phase 5A. And you can also find out which of these compute nodes is free for you to use right now using the what's free command. Okay, so you see that, for example, in phase 5A there are 374, all right, I'm not sure about the discrepancy there, but there's 374 nodes in total, out of which 338 are free. Offline nodes are not available for you to use. And then again, you have a lot of that information from etc hardware table being repeated. Okay. So everyone clear so far about what's on the cluster and how you can figure out what's there on the cluster and how to look at that? So what's free and cat etc hardware table are two commands you'll find yourself entering quite a bit. Let's try a few more interactive sessions just to see what kind of resources we can request from the cluster. Okay, so remember that to bring up your previous commands, you can use the up arrow. So here's our first resource request. We ask for one node with one CPU. All right, which phase do you think that node is going to live on? Any guesses? Anyone? Actually, who's going to decide that? The scheduler decides all of these things, right? It looks at your resources, it looks at what's free, and then it decides where to put you. You have very little control. Well, actually, you do have control. You can, for example, specify the phase that you want to be on. Okay, so you can say phase 5A, and that guarantees that you get put on a node that's on phase 5A. And if there are no free nodes available here, then you'll just keep waiting till a node gets freed up. Okay, but because phase 5A was relatively empty, we get put on it, and you can confirm the number of CPU cores there are by typing in the ls-cpu command, for example. And that gives you some information about what CPU is available here, and it's some data about it. So we know that phase 5A is supposed to have 8 CPU cores, and so you see that this node actually does have 8 CPU cores. All right. Any questions? Yes.